as far as these quadratics go, we're going to look at vocabulary first. All right, so a quadratic function is going to look something like, and we're going to use function notation, f of x is equal to ax squared plus bx plus c. All right, now we've done these before when we were doing our factoring, except we didn't have the f of x equals on there. We just dealt with the ax squared plus bx plus c, and we graphed we factored those. We factored them with slide and divide. We factored them when that a was a 1, then we did the little box to guess and check it. All right, now we're just adding an equal sign and an f of x. Then this is actually called a function. This is that function notation. Okay, now written like this with an x squared and then a plain x and then a constant, this is standard form. So for the most part, they're probably going to give them to you in standard form. If not, you could rearrange the terms, and you could put the x squared term first, the x term, and then the constant, and you could rearrange it and put it in standard form. All right, now let's put in parentheses here parabola, because that's the other words. When we look at these graphs, we usually refer to the graphs as a parabola. All right, they come from the quadratic functions. We're going to have the U shape. A parabola is a U shape, and I'm pretty sure even we have looked at these earlier in the year. Okay, so we could have a parabola that looks like this upside down. We could have a parabola that looks right side up. Okay, and I made both of these pretty wide. They can be really wide, they can be really narrow, skinny. I did not put these on a coordinate plane because I just want the general idea of what the graph's going to look like. Okay, now when it's an upside down, this is considered to be an upside down parabola, it has a highest point. That would be the highest point on the graph, because if the graph goes on forever and ever and ever in the downward motion, that's the highest point. So then that is referred to as the max. It is a maximum. So we're just going to say it's a max. All right. It is called the vertex. All right. So the point that is the maximum in that case is called the vertex. All right. Now this one over here is an upright parabola. And instead of having a maximum, if this parabola goes forever and ever and ever in the upward direction, then this is referred to as a minimum. So you're going to have to, we're just going to put min, but minimum is the word you're going to see in Math Excel. All right, and again, that is called the vertex of the parabola. So you're going to have to identify, they'll ask you to identify the coordinates of that point. We'll do that when we do one on graph paper. You're going to have to identify whether or not it is a maximum or a minimum, okay? Now, something that if you've not been told or yet memorized, how do we know when it's upside down or right side up? This is upside down, this is right side up. We take a look at that A coefficient. All right, when the number A is positive, I'm going to put this in the middle right here. When A is positive, we know it's an upright parabola. If that first number is positive, we know it's an upright parabola. If it is a negative number, then it's an upside down parabola. So when we were looking at these quadratic equations and we were factoring, all right, we didn't have this part, but if you remember, sometimes there was a negative in front. All right, and then if we would have went ahead and looked at what the picture looked like, looked at what the graph looked like, every time it was a negative in front, it would have been an upside down one when we graphed it. When it's positive, it would have been right side up. All right, so how much of that stuff did we already know? Had we heard some of this before? I'm getting mixed. Some people are saying yes, some people are saying no. Okay, so if you're not, then you've got vocabulary and things to memorize. All right, things to memorize. One other thing, we're going to, you can't necessarily tell by the way I hand sketch these, okay? But they are symmetrical. All right, so there is an imaginary dotted line that's going to go right down through the center, all right, which means the left-hand side is going to match what's on the right-hand side. This is going to be called our axis of symmetry. And it is a dotted line because it's not part of the graph. All right, so you might have to identify that axis of symmetry. Every parabola has one. All right, it always goes through the vertex. All right, so again, that would be my axis of symmetry. Now, if I know the vertex, if I know the coordinates of the vertex, then I know the equation for that imaginary dotted line. Okay, let's say that the coordinates of that vertex right there was 3, -5. All right, if the ordered pair that point goes through on our graph paper is 3, -5, my axis of symmetry is x equals 3. Okay, it matches the x coordinate of the vertex. So if the x coordinate of the vertex is 3, my equation is x equals 3. So it's the exact same number. If I told you that the vertex right here was the point -2, 8, if that vertex right there was -2, 8, the axis of symmetry would be x equals what number? -2. Because it is always the x coordinate. So whatever number goes there, and that's how you write the equation of that axis of symmetry. Okay, so every parabola has an axis of symmetry. You have to make that line dotted because it is not part of the parabola. The parabola is just this. It'll have a vertex. That vertex can either be a maximum or a minimum. And deciding whether or not it goes upright or upside down, you look at the leading coefficient of that A right there, and that tells you whether or not it's an upright or whether or not it's an upside down parabola. All right, so questions over that part so far. Okay, so pretty straightforward. Okay, now let's take a look at if we were going to graph one of these. Okay, so we're going to use some of our graph paper. We'll do a relatively simple one here. I'll darken that up so we can see those lines on that graph paper a little bit. All right, let's suppose it did say graph. All right, this is going to mimic what we did with our linear equations. Let's suppose I had, as an example here, we'll do a real simple one. Y equals 1/2 x squared. All right, so that number right there is my A number because that's my x squared term. Now, this is in standard form, even though it doesn't have all the other terms. All right, it doesn't have an x term, so plus a 0x because that's not really there. All right, plus 0. I mean, if you're needing to see that standard form, ax squared plus bx plus c, it really is in standard form. It's just we didn't have a c and we didn't have a bx, and that's okay. Those would be zeros then. But that clearly then indicates that that 1/2 is an a. Now, is it positive or negative? It's positive. So is it upright or upside down? It's upright. Okay? So because this is positive, I know that when I get done graphing that picture, it better be upright. All right, and if it's not, I know I've made a mistake. Okay, now what we're going to do is we're going to do that XY table, and we're going to do an extended XY table just like we did initially when we first started graphing the lines. We made a column for X. All right, we left a really wide space in the center, and then we have a Y over there because we want some ordered pairs to be able to graph this. Okay, now if you remember, it's been a while, all right, but we took everything that was to the right and we plugged it in right here. So I'm going to have a 1/2 x squared. In other words, my function is going to go there in the center, whatever it happens to be. So if there were more pieces and parts, the entire thing would go right there. Now, right, for this beginning section, all of our parabolas are going to be focused around the y-axis because they're going to be pretty simple ones. Okay, so what I'm going to have you do is I'm going to have you pick 0 in the middle. Okay, so come down a little ways and put in a 0. And then we're going to pick a couple numbers that are positive and a couple numbers that are negative, because then that's going to put numbers on both sides of the arms of our parabola. So let's put a 1 here. Now let's not use a 1. Let's use a 2 and let's use a 4. I'm going to strategically pick numbers so that they'll come out nice. Alright, I could have used a 1 and 2. Everybody in the room could have used different numbers, but let's do 2 and 4. And then let's do a -2. And then let's do a -4. Now, we ought to see some patterns. Just like when we did this with linear equations, we ought to see some patterns in this because we know it's going to be symmetrical, right? Now, order of operations. Let's do the 0 one first because that's going to be easy. I'm going to take x equals 0 and I'm going to plug it in. So I'm going to have a 1/2 times 0 squared. Well, 0 squared is 0. 0 times 1/2 is 0. Okay, so I started with that one because I knew it was going to be really easy. This is my x coordinate. This is my y coordinate. So that means 0, 0 I know is on my graph. So then I can come over here to my graph paper and I can put a dot at 0, 0. Alright, from there I don't know which one's going to be easier. It really doesn't make any difference. We're going to let x equals 2. We're going to plug it in. So I'm going to have a 1/2 times 2 to the 2nd power. Now you got to follow order of operations, which means I have to square 2 first. So 2 times 2 is 4 times 1/2, 2. Half of it. Okay, so again, I take this number as my x coordinate. I take this number as my y coordinate. So that gives me 2, 2. Alright, so I'm going to plot that point. When I come over here, I'm going to go 2 to the right because that's the x coordinate. I'm going to go 2 up, and that's my y coordinate. Alright, let's go ahead and plug in 4. I'm going to let x equal 4, so I'll have a 1/2 times 4 to the 2nd power. 4 to the 2nd power is 16. 4 to the 2nd power is 16 divided by 2, 8. So then that's going to give me 4, 8. And we'll see if it fits on the graph paper. So I'm going to start at the origin and plot the point 4, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. I'm only off by 1. I think 8 goes on your graph paper. Now, technically, I told you this was symmetrical, right? So do I really have to do these two? Because we can see the shape of this. If this side is symmetrical to this side, then do I have to do -2? When I plug in -2, what number am I going to get? Not -2. If I plug in -2, I'm going to get +2 because it has to be symmetrical. So let's do the math and see if it does work out that way. 1/2 times a -2 to the 2nd power. Well, -2 times -2 is 4 times 1/2, or divided by 2 is 2. So then that gives me the ordered pair -2, 2, which means I start at the origin, I go to the left 2 and then up 2, and that point is symmetrical. Alright, which also means then I've got to have one symmetrical across from this one. So instead of 4, 8, it's going to be -4, 1, 2, 3, 4, 8. So, you can do half the points and then just make them symmetrical, and then you know that you've got enough. I'm going to go ahead and connect them. I should make it look like a U down here. Don't make it look like a V. I've actually graphed the parabola. Alright, now from there I can add an axis of symmetry. It's going to go right through the vertex. Alright, when we add that axis of symmetry on there, we should be able to make the equation. It's always going to be x equals whatever the x coordinate is right here. What's the x coordinate right there? 0. So my axis of symmetry is x equals 0. Okay, now what else can we say about this? What kind of point is this? Is this a max or a min? Min. Someone said minimum. So that's a minimum. What is that point called? It's called the, starts with a V. It's the vertex. Alright, now I can list the ordered pair that goes with it, 0, 0, because it went right through the origin. So you ought to be able to give the vertex of the parabola as an ordered pair. You ought to be able to identify that vertex as either a max or a min. In this case, it's a min because it's the bottom point. You ought to be able to identify the fact that this is the axis of symmetry. It's a dotted line. It goes through that vertex. And the equation of that axis of symmetry, let's actually label it axis of symmetry. And then that equation for the axis of symmetry is x equals whatever the x coordinate is. All right, so we ought to get to the place where we are able to identify a lot of different pieces and parts. All right, now today, for the most part, that's probably about the only thing you're going to have to do. You're going to have to identify maxes and mins, find the vertex, be able to graph it with graph paper. All right, questions? Okay, all right.